The energy of life is a buzz. And we are here to give the energy of life to people and revolutionize the fight against malaria. When you were growing up, what did you want to become? What dreams did you have? For your children, what are your hopes and aspirations? What do you want them to become? Well, how about a statistic? Because that is what a very large number of children end up becoming. Just another number. Good afternoon, ladies and gentlemen. We are Team OneBuzz from New Zealand. And today we are here to share our malaria intelligence system with you. And we use the Millennium Development Goals as a guideline. And what we saw was that malaria directly restrains the achievement of other Millennium Development Goals. Malaria is a mosquito-borne disease that affects nearly 300 million people a year and claims the life of nearly 1 million, mostly pregnant women and children. And it not only kills children, it kills families, destroys villages, ruins economies. Malaria kills futures. Now think about it, as malaria is preventable and curable, provided that you have access to the right resources at the right place at the right time. Globally, we are spending about $1.8 billion on malaria control every year. But the problem is that the World Health Organization estimates the cost to be $6 billion a year. As you can see, we have a huge shortfall between what we have and what we need. Simple solution, get more money. Well, if it was that simple, it would have already been done. So in reality, what we have to be is super smart and super efficient in how we allocate the scarce resources at hand. Because in this scenario, efficiency drives effectiveness, which helps save lives. Now let's look at some of the main methods we are using to control malaria. Spraying larvicide at the breeding grounds, nets to prevent from bites, and medication to cure the infection. But the problem is that these resources are being delivered haphazardly and inefficiently without enough information from on the ground. Now let's look at some of the questions that we are facing today. Well, where are the breeding grounds of mosquitoes? We don't know. Where is it best to spray? We don't know. Where do we need to get the medicine to? Where are the outbreaks occurring? We don't know. Have we got the right levels of medicine at the right place at the right time? We don't know. In essence, what we have in our hands is a global epidemic, too many questions and not enough answers. That little mosquito, it's winning. Malaria is one small bite for a bug. We are going to give you one giant bite back for mankind. But before I show you the solution, let me take you through our journey. Now I know firsthand the pain it causes. My mother had malaria when she was pregnant with me. And I had it twice when I was growing up. So today I'm proud to be part of OneBuzz, which is a revolution in the fight against malaria. Now, you see, this fight, it's personal. And because we are all engineers, we recognize that we are lacking expertise in malaria epidemiology. So we worked through our networks, and that's where we found Dr. Nick Douglas, an expert in malaria epidemiology. He was so excited to hear about the OneBuzz solution that he became a part of it, and is here today to support us. Now, we read extensively into the medical literature on prevention, treatment, and the burden of malaria. And what our research showed us is that countries face huge problems of stockouts of medicine, inability to track wetness distribution, and difficulties in identifying priorities for where to spray. And to put simply, the resources are not available where they are required the most, and in essence, what leads this on to is people dying. Now, let me show you the reality of what happens in the developed world. A doctor, pharmacy, electronic medical health records, everything is tracked and managed. Now let's see the health experience in the developing world. A pharmacy, a clinic, no. It's a hut. As a consequence of this, they do not know where the medicine are, where the outbreaks are occurring, and what medicines are available. So let us share with you a solution how we answer these problems and find a solution to these. Now OneBuzz collects data from the ground and data from the sky to plan, execute, and manage malaria control strategies. Let me start by showing you how we are using power of simple mobile phones. Now before you think about mobile phones in the middle of Africa, let's give you a few data points. There are about 1.2 billion mobile phones in India and Africa alone, similar looking to these. They are being used for multiple different applications currently. And we are going to use the power of simple text-based solutions to fight the problem of malaria, which allow health workers to do simple things, such as text in and report in the number of patients they have seen and the number of deaths they have noticed. And every week, they text in the amount of stocks of medicine they have available in their clinics. Now, currently, all of this data is handwritten on paper and on books, which can take months to deliver depending on how remote the location is. Then it sits on headquarters in tables weeks before it's being analyzed and converted into knowledge. And by this time, malaria outbreaks have occurred, stockouts have happened. Let me show you a scenario how we are going to use our solution to fight this problem. Now here we are logging into the system as a district malaria health officer. He's responsible for allocation of medicine resources in his clinic. Now there on the left, bottom left, we see different clinics underneath his management. And the information is extracted from incoming SMSs and sent by the remote health workers and displayed on the graph on there. And these are the stocks he has in different clinics available to him. And what we can see is that Chandi Clinic has run out of stocks of medicine. And here, and highlighted in the blue, is that the person has already requested medicine to be sent to this clinic which is in transit, from which warehouse and what is the number of stock he has sent. But you see, the system is still reactive. We are reacting to a stockout which has already occurred. What we need, we have to be preemptive. What we need to be is be able to predict the stockouts and get medicine to them before they know they need it. Let me show you how the Buzz can handle this. Now, the growth of spread of malaria is dependent on a host of different factors, such as humidity, rainfall. And malaria is seasonal and cyclic. So the historical pattern of cases of malaria from last year and the cases of malaria from the last few weeks are very useful in predicting the growth of malaria in the upcoming weeks. Now, all of these factors are entered into a moving average time series regression model, same to those used for predicting the currency exchange rates. Now, this can be used to actually raise an alert, which we can see visually on the system here. When we click on it to investigate further, what we see is a graph of the cases that has been reported. The blue line here represents the cases from the last year. The green line on the left represents the cases which have been reported in from the last few weeks. Now the system has predicted, the green line on the right is the growth of cases that the system has said they are going to happen in this region. Now because we know the torrential rains, the monsoons are coming earlier this year, that's why the system has raised this alert. Now when we click on the stocks tab to investigate further, what we see is visual representation of the amount of medicine that will be needed. The bars here represent and show that the clinic is going to run out of medicine and will not be able to cater to the demand that's going to happen. Now what we can see here is that the OneBuzz solution doesn't stop there. We go a step further. We can enter the amount of medicine that we need to be sent, what type of medicine and from which clinic. And when selected, we can post a request in, which goes into the server. Now the system updates us further. It says that this clinic approximate time of delivery is going to be 16 days from this warehouse. Then they still will not be able to cope up with the demand. So what the system allows us now is, because we know which clinics have what stock, the malaria health officer can request an emergency stock transfer of some medicine from which clinic which is close by to this one. So the system shows them that clinic, lets them request it, and here we know now that when the malaria cases go up, the clinic will have enough medicine to treat this patient. Now, this is an example of how we are driving the efficiencies to help save lives. Now, Edward is going to take you to the magic of the sky.
Here we are logging in as Ashok Kumar, the State Administrator for Bihar. His role is to plan at a high level how best to allocate all the resources at hand to all the different people fighting malaria in his state. Upon logging in, we can see on the left the total stock reserves of the different types of resources he has available. And on the right, you can see a simplified history showing both requests for stocks and how they are flown in and out of the different warehouses. Now, let's see how OneBuzz can help Ashok deploy some of these resources more efficiently. Bed nets are one of the most effective interventions against malaria, but until now, there's been no easy way to track where previous deployments have happened, who has access to nets, and when they will reach the end of their useful lifetime. But using OneBuzz, we can collect and combine information about the previous net deployments and their usage patterns to visualize this information intuitively on a map. And as you can see, it's now easy to determine which districts have poor or good enough net coverage, as represented by the clear and opaque circles respectively. Zooming in further, we can see the effects of the individual net deployments and, consequentially, which regions do not have very good access to nets. Using this information, it is easy for a shop to decide and select a region that he wants to send nets to. Clicking on this region, you can get useful information about net deployment, such as the area it covers and an estimate of how many people live in it. You can then use this information to specify the type of nets you want to deploy, how many, from which warehouse, and, if needed, add any extra specific notes about this particular deployment. What we've shown you so far is focused on the researchers, is focused on the people who use the malaria research models to deploy the resources out in the field. But the scientists and researchers who create these models face their own problems. To investigate areas such as landform classification, breeding ground recognition, risk map generation, and antimalarial effectiveness, they need access to high-quality remote sensing data and malaria case trends. But the problem is there's far too little collaboration between all the different organizations involved. OneBuzz aims to bridge this divide and unite malaria aid organizations, researchers, and database providers. We have already integrated several different mapping projects and GIS systems within our solution, and we're working very hard to bring in even more in the coming future. But we know that we can't implement everything ourselves, so we provide a simple and open API so that the researchers themselves can build upon and extend our system. To demonstrate how feasible this is, we have worked with researchers from the Imperial College London and Caltech University to develop a plugin that identifies and prioritizes where to larvicide and perform indoor residual spraying. The way this works is simple. We couple geographic information systems and image processing algorithms with a knowledge of mosquito ecology to identify the bodies of water where mosquitoes breed and the places where people live. But the amount of resources is still limited, so to maximize efficiency, we prioritize based on how close the mosquito breeding grounds are to people, and then further limit the search to within a few kilometers of cities and villages. So how do we find these places anyway? Well, we have adapted image processing and pattern matching algorithms that work with hyperspectral satellite images. The different component frequency bands are combined together to build a per pixel spectral fingerprint at a high spatial resolution. And then using this, we can determine where there's water and where people live and are at risk from an area. But remember, it's not just about the research. It's about bringing the research to the people who need it out in the field. So we take it a step further and make it possible to overlay prioritized spraying instructions on top of big maps so that this research is immediately available to the health workers out in the field. It's quite simple, really.
It's not really that simple, Edward. That's why you're doing a PhD. I will now take you through the software architecture of our OneBuzz solution. In essence, what we're using is a Windows Azure infrastructure to be the data repository and from where we host the management platform to collect, aggregate, visualize, and share this data with anybody, anywhere, and anytime. We've used Microsoft Silverlight to be the engaging, real-time, and dynamic user experience for the OneBuzz application. It is compatible with multiple operating systems, browsers, and devices, bringing a whole new level of interactivity and reaching a far greater audience. We're using the Microsoft development tools, such as Visual Studio and the .NET infrastructure, to build the solution with open APIs and keep the application open to extensions. We've also created a Windows 7 phone application that allows users to access all the information on the Azure cloud, such as where stockouts of medicine are happening. These also act as rapid survey data collection devices with geolocation capability. Now, we have shown you that malaria is a huge problem. We've come up with a solution, and we've validated this solution with people working in the field who see great value in this. We approached various organizations to see what they think of our OneBuzz idea. Let me share with you the buzz about the buzz. The Institute of Malaria Research, the biggest organization fighting malaria in India, actually invited us. We traveled to malaria-stricken regions in India and spent an entire month on ground with them to understand the problems they are having firsthand. And today, I'm proud to announce that we have now formed a strategic alliance with the Indian Institute of Malaria Research. While in India, we also validated our satellite image processing algorithms. The risk maps we generated were matched against previous on-ground risk maps. We achieved a 76% correlation, and that is just using satellite images. With the remote sensors that we have developed, the level of accuracy of our risk maps will increase dramatically. Here's what they had to say about our OneBuzz solution. It has a great advantage with its real-time capacity to inform and track information. This is the exact blend of real-world technology and future thinking that we need to fight and win this war. They're looking forward to the field trials that we have planned in the near future. Hewlett-Packard has been one of the leaders in global citizenship for more than 6 decades. They have extensive experience with fighting malaria in Africa. Here's what Paul Elligstad, Global Health Director of the HP Office of Social Innovation, had to say. The OneBuzz team has taken an innovative approach to tackling malaria based on a solid understanding of the problems inherent in the existing response processes. They've leveraged technology in an effective, appropriate, and useful way that has the power to be transformative in the fight against malaria. So, who will pay for our solution and who will use it? Well, the payers include regional governments, NGOs, and multinational aid organizations who will be seeking to get a dramatically improved return on their investments. They spend millions of dollars currently every year to fight malaria. The end users will include malaria control agencies, local health agencies, and researchers. Our business model will be centered around a software as a service model with in-market alliances. We will charge on a pay-as-you-go basis to cover the costs of running the OneBuzz solution. These costs include the acquiring of specialized satellite images, setting up of a free text number, the Azure cloud service, and the general costs of operating a business. We've already started our incubation with the world's premier business incubator, the ICE House. We're working very closely with them to refine our business model and prioritize opportunities. Our initial plan is to deploy our system in the state of Bihar in India, where malaria is still endemic. This field trial will allow us to customize our prototype and further refine the OneBuzz solution before taking it into other malarious countries around the world. To give you an idea of the future developments of our system, we've been working very closely for the last 3 months with the University of Vigo, with strong collaboration with the European Space Agency. In conjunction with them, we have developed these satellite sensors. The sensors give accurate information on local factors such as humidity and temperature, which will allow us to drastically improve our malaria prediction algorithms.
Not so long ago, in the 1950s, for most of us in the room, that's our parents and grandparents, malaria was endemic here in the United States of America, in the backwaters of Louisiana and the Everglades of Florida. We got rid of it. We fixed the problem. But I can assure you, if kids were dying here today due to malaria, we would do something about it. So I want to ask you to let's not make this an us and them world. This is the one fight for our generation we need to take a stand on. Previous generations have had their fights against racism, fascism, and apartheid. This is the fight for our generation. Now we know we don't have all the answers yet, but hopefully what we've shown you is that malaria is one of the world's biggest problems and we can help solve it. And people working in the field think we are onto a real winner here. Now, as Senator Kennedy once said, few will have the greatness to bend history itself, but each one of us can work to change small portion of events. And the total of all these acts will be written in the history of this generation. So I want to ask you to let's make an end of malaria as a part of the legacy of our generation. Please, join the revolution. OneBuzz.
mentioned talking to agencies, which is very noteworthy. But what did you learn from their feedback that you changed in the system as a result?
I'll give you an example. When we were on the ground, we were talking to a few women who were at the clinic, and what we found out was a lot of times they have to go to clinics, walk 3 to 4 hours and get there, and they find out the medicine isn't available. So a system which we incorporated into our OneBuzz solution is that you can text in your geolocation code for that might be a postcode or a village name, and the system will text you back the closest clinic that has medicine. So even before you leave your house, you know which clinic to go to have medicine. Little things like these we've incorporated, taking on the user experience on board and trying to make the system as more efficient and user-friendly as possible.
Thank you very much. And following on from that, how much do you plan to educate the user? Because of course they have to know the technique, they have to know to be able to do it.
Yes. So what we have done is we have created the templates first of all for the clinic workers in their own language. So for India, we've used Hindi so that the texts that go out to clinics, pass information from them are in their native language. And yes, what the aim is to educate the people who are coming to the clinic so they can help spread the word. Because you see, this is a problem that people are facing themselves. So the uptake of the solution will be high because they want such solutions to be available.
I'd also like to add that the health workers in the clinics are already doing things like taking the numbers of stocks and cases. What we're asking them to do is enter the numbers through a simple text interface, which they're already used to.
I've typed numbers in on mobile phones over many years. If I mistype a number, if I say 200 rather than 20 cases, and it goes into a text message, what happens next in your system?
Because first we keep track of what medicines they had previously. So not only do we get the number and we correlate that number to what they had texted in before. So first we check for clinic capacity, that if the number doesn't make sense, we have a threshold for each different clinic which we can set for. So first we test against that. So that if the number doesn't make sense or is a different character, the system can automatically send a reply back. If it does not make sense, can you please correct it?
If I'm reporting cases in my area, malaria,
or cases?
yes,
or not
numbers
stocks
going into your system incorrect, what happens?
Well, first threshold that we've set, again, cases as well, we are comparing against last year. The case information history is available, it's just not available as soon as we need it. So it has to make sense, because if texts are coming in from a certain village, which has a population of, a surround population of 10,000 and the number says 100, does not make sense. So we correlate it to the database which has numbers from previous year's history.
So something would like to have read somewhere saying there's a question about this matter.
Yeah, and we'll ask them to send a confirmation back.
And it will also, the person who logged in, when they log in, it will bring up an alert that something went wrong. It's not just computerization, so human interaction will take place after that.
And that's in the system now?
Yes.
What kind of, you mentioned upcoming field trials.
Yes.
What are you focusing on for the next 12 months?
First thing, when we are entering beyond, what we are focusing on is, as the judge mentioned, is that you have to educate people as well. Even though they know how to use the system, there will always be problems you face when you go out in the field. So for 6 months, what we want to test is the validation of these sensors, incorporate this in satellite images, see what happens, as Rob mentioned, when different texts are coming in and they don't make sense. So make the system as foolproof as possible, because we don't want to lose credibility. So we have set this 6 months aside just to do all the tests that we possibly can before we move to bigger and better deployments.
Can you describe your software solution in one sentence?
The revolution in the fight against malaria.
Well, what about the feature set? What is the core feature of your software in one sentence?
So our solution is essentially a module system whereby you can write modules to manage different types of resources from different sources and gather data from different sources such as mobile phones, existing stock management systems, and so on.
See, one thing I'd like to add, this is not just one system. There's 3 different systems combined together. And you can have access to multiple different systems. You don't have to need the whole thing.
That was more than one sentence. Yeah. Thank you, guys. That's awesome.
And please, do you have any strategy to attract investors?
what Kaya mentioned, the Ice House, they've been ranked by top 10 in the world by Forbes magazine. And they took us, we pitched this idea to them. And what they have said is we're looking for venture capitalist funding to come on board as well. We're also applying a grant to the Gates Foundation to help us take this ahead.
So what do you see as the advantage of your system over supply chain management systems being used by existing agencies combating malaria? What advantages over supply chain management systems does your system have?
I mean, one point about that supply chain systems are still reactive. They're not preemptive. They're not using prediction models merged with them. So they do not send in medicine out before the clinics need it. Second thing, in many regions they do not know which clinics need medicine when. So we're putting intelligence into the supply chain management. Anybody want to add something?
Can I just ask, if you're effective in your data collection and deployment of that and using that information, you anticipate that the numbers of malaria will reduce?
Definitely. Because you see, it's not just about treating the problem, it's about preventing the problem. For example, the bed nets and spraying. Now, spraying of larvicide is very important because it can stop the growth of the larva. And again, we are using brute force at the methodology at the moment. They start at one end of the village, keep spraying till it finishes. They do not know where to prioritize. So if we can tell them these are the exact regions you need to go and spray to stop the spread, that will definitely reduce the cases of malaria.
Well, also, how much resource and funding will it take to transfer this system from a small area in India into Africa and the rest of the world?
Now coming to the aspect in terms of the spraying, the only main requirement is satellite images. For India, we have done collaboration with the IMR, Indian Space Research Organization, who has given us access to the images for free. We also did research on how much is it going to cost in other countries. For example, in Nigeria, the cost to get the whole country's satellite images is about $5,000. So scaling up and costs are not that high in the system.
You have a system where I can find out which is my nearest stockist of malaria. If I ask for that number and 10 people around me also ask, is there any in stock? Does your system do anything to make sure that we don't, only 9 of us get the medicine and the 10th person doesn't?
So we're keeping track of how many texts are coming in asking. And we're also keeping so we know who asked us for which and what did we reply to them.
We are keeping a minimum threshold as well. We're saying that the clinic must have this much at all times.
So you're not going to have a situation where 10 people set off, only 5 people.
5 people will get the medicine.
So we would actually recommend them to go to a clinic which is actually running dangerous and stock, where might have visit.
Because it's real time.
You've also got on your maps, you said we can draw an area and it will tell us how many people live in that area. Where does that data come from?
We're using a third-party service which provides a gridded population tool, which estimates that they vary by something from census data.
But that data is just for India. So they have a relationship, the third party has a relationship with the consensus of India, and we have that data available. But a lot of different countries have that data as well. Some cases you might have to manually enter it, but predominantly it's central. And it's a very estimate of how much next you want to send in. It's not a very accurate number.
I'm finding it really hard to find a question, to be fair. Great presentation, guys. Spot on. So really, I'm going to try and help a little bit. What is the biggest barrier that you've got?
The biggest barrier initially it was that people thought of us as students. What can you do about this problem? But platforms such as the Magic Cup has given us that credibility that we can go and approach people and say, see, this is what we have done. We have got collaborations going on. Please take us on board. It's about creating the partnerships because in this day and age, you can hardly achieve any big goal alone. Creating those partnerships will be our biggest barriers, but I think we are on a right path to create them.
So what was the largest systems integration issue you faced, and how did you overcome it?
Sorry, can you please repeat?
What was the largest or the systems integration problem you faced in creating the system, and how did you overcome it?
The major one is that all the existing kind of database softwares use slightly different formats, and so we actually need to write kind of different modules to actually support all the different systems. There's no single kind of interchange format for all the startup.
We don't have time for you to answer this, but Rob mentioned the fact figure which potential data errors that
Yeah.
occur. I think in your solution, and I'll talk to you more tomorrow at the booth, data quality is at the heart of what, because ultimately you're doing predictive analysis. So think about field testing and how you're going to test and catch those data errors that are inevitably going to happen because you're going to make life decisions.
And we definitely agree with you, and that's why 6 months, that's all we're going to do.